Hello students. Dear students, in this lecture we will see some concepts of a set. First one is subset of a set, second one is union of two sets, Cartesian product of sets. First we will see what is subset. Let A and B be two sets. Then A is a subset of B if all elements of A are elements of B. That is, the set A is contained in B if and only if every element of A is an element of B. If A is a subset of B, then this can be written as A is subset of B or A is contained in B. For example, consider a simple example. Let A is equal to A, B, C, D. Then I have taken B is equal to A, B, D. Then see here, each element of B is again element of A. This small a is in B and is an element of A. Small b is in B and is an element of A. Small d is in B and is an element of D. So each element of this set A is contained in B. So this A is a subset of B. See here, note that A is a subset of B, but A is not equal to B. Why A is not equal to B here? Because the element C belongs to A, but C does not belongs to A. Therefore A is not equal to B. As this element C belongs to A, that is the element C is an element A or C is contained in A, C belongs to A, but C does not belongs to A. Therefore A is not equal to B. But A is a subset of B. And there in this case, and here A is not equal to B, then such subset B is called proper subset of A. Proper subset of A. This is the one example. You will take another example, that you will take some more example, that is, you can see here this natural number, set of natural number is a subset of set of integers I or Z, because each natural number is an integer. In this case here, this proper subset, if A is a proper subset of B, then in this case we write, in this case A is a subset of B, A is not equal to B, then in this case we write A is a properly contained in B or A is a proper subset of B. How this can be read? A is proper subset of B. Proper subset of B means what? A is contained in B, A is a subset of B, but A is not equal to B. So here N is a subset of A. Here N is not equal to I, because minus 1 is contained in I and minus 1 is not in N. Therefore this here N is the proper subset of, you may take Z or I. N is a proper subset of I. This is a concept of subsets. Now we are going to see, or you may take third example, that take any example. Here we also know that this set of integers Z is, again, this is a properly contained set of rational numbers, because each integer is a rational number. So many examples we will take. Then now we will define union of two sets. For that, let A and B be two sets. Let A and be two sets, be any two sets, then A union B is denoted by A union B is denoted by A, this U B, or this is called A union B, and this is again a subset. This contains all x belongs to A or B. This contains all the element x such that either x belongs to A or x belongs to B. This is the union of two sets. The intersection of two sets. So intersection of two sets. We have seen intersection of two sets A and B. Suppose let A and B be two sets. Then their intersection is denoted by, this is called A intersection B, and this contains all elements x such that x belongs to A and x belongs to B. This is the intersection of two sets. This is the set of all common elements from A and B, which belongs to A as well as B. This is contains all elements x for which x belongs to A and x belongs to B. For example, consider an example. For example, let x is equal to, let you may take capital X is equal to, you may take some example -1, -3, 4, 5, 9 and 10, and capital Y is equal to, you may take 0, -1, 5, 10, 15, 20. Then see here, what is their union and intersection? Then x union y is equal to, what is x union y? What is the union? Then this union contains all elements x where either x belongs to A or x belongs to B. So this is the set of all elements, collection of all elements x where either x belongs to this capital X or x belongs to this capital Y. See here, this, so -1 belongs to x, so we have taken here -1, also -1 belongs to y, -3 is also there, -3, 4 is there, take 4, 5 is there, 9 and 10 is there, 9 and 10. From set y, 0 is there, write 0, and from -1 we have already taken, 5 also we have already taken, 10 also we have already taken, so 15 and 20. So this is the x union y. This is the x union y. By using Venn diagram we can see that. See here, this is your x, this is your x, and this is your y. So you can also calculate x intersection y. So common elements which are in x and y. So here -1 is in x and this -1 is in also y. So this belongs to intersection, common elements. -3 is also in x, -3 is also in y, so -3 also comes in this set. 4 is in this set x, but 4 not in this set y. 5 is in this set x and also 5 in this set, so 5 also comes in this intersection. And 9 in this set x, but 9 not in this set y, so this is 9 does not belongs to intersection. 10 is again a common element. So these 4 elements are in the intersection. See here, what is x here? What is the first we can write? This is the x intersection one. This part is called x intersection one. This part is the x intersection one. X intersection y. And what is the union part? If you want to take a union part, then this whole, either x belongs to this whole part is a this complete part is a X union Y. This complete part is a X union Y, this part, and this complete part is X union Y, but mainly here X intersection Y is shown in the this is the X intersection Y. See here, this is the X intersection Y. So this, let us see some more concept regarding this set. Cartesian product of two sets. Cartesian product of two sets. Product of two sets. Cartesian product. So for that, consider, let capital A and capital B be any two sets, then Cartesian product of A and B is the set of all ordered pairs A comma B, where A belongs to A and B belongs to B. This is the definition of Cartesian product of two sets. The Cartesian product of two sets is denoted by or it is denoted by A cross B. That is, what is Cartesian product? Then A cross B or A Cartesian product B is equal to, this is the set of all ordered pairs such that A belongs to A and B belongs to B. See here, we have, these are in ordered pairs. These are pairs where this first A is the first component, B is the second component. So this first component must belongs to A and this second component B must belongs to B. So this is the Cartesian product of two sets. For example, let take a simple example. A equal to 1, 2, 3 and B is equal to, just take A comma B. Then what is the Cartesian product of A cross B, A and B? A cross B. Then what is A cross B? How you can, A cross B is again a set. This is set of all pairs. So A cross B means what? These are the pairs of the form A comma B, where this first component A belongs to A. So first component of A is 1, therefore 1 comma, we have to take second component from B, so 1 comma A. So this is 1 comma A. Second element from A is 2, or we may take A fixed here, 1 fixed, 1 comma A, 1 comma B. First component is from the set A, second component is from the B. So these are the ordered pairs. First one is 1 comma A, second one is 1 comma B, third one is 2 belongs to A and A belongs to B. So second one is 2 comma A, next 2 comma B, next one is 3 comma A and 3 comma B. This is the Cartesian product of two sets B, A cross B. But what is B cross A? This is A cross B. Similarly, we can define B cross A. What is B cross A? For this example, we have to take the first component from this B. First component, what is the elements of B? A and B. So we have to take A first component, A as a first component. So A comma 1. So A comma second component from A. So A comma 1. Next first component, take A as a first component. So A comma 2 and A comma 3 are the next pairs. A comma 2 and A comma 3. Next one is B comma 1, B comma 2 and B comma 3. This is B cross A. Do you understand, students? Okay, thank you, students. In the next lecture we will see relation, types of relation and some example based on relation. Thank you.